Hello, everybody. So what we're going to be doing today is the Week 10 Lecture 2. This is the second lecture on arrays. So if you look at our previous lecture, Lecture 1, there was a set of lecture slides on arrays, and then we did some Zybooks exercises. And Lecture 2 is going to be pretty similar, except that we're going to look at another set of lecture slides and do more Zybooks exercises. So let's get started. So I'll download this set of lecture slides here. Um, hmm, Hopefully this is the right link. It is. It says lecture 10. I see it. Okay, here they are. So in order to watch this one, you should have previously gone over the other array lecture and maybe have already done a lab 10. But what we're going to be doing in this lecture is kind of more advanced topics involving arrays, just a lot of different things that we can do. Like we could add up all of the entries in an array. That's one thing we could do, find the sum. We could calculate the average entry in an array. We could multiply every entry of an array. We should or we could count up all of the entries that satisfy some condition in an array. And we should be able to find a maximum or a minimum. And these different things here, which are all in this set of lecture slides, show up in the Zybooks assignments as well. So here's where we'll start. So finding the sum of the entries in an array. So consider that you have an array like this one. So this is an integer array called my array, and it has four values, 5, 8, 12, 5. And if you wanted to add those up, this is what it would look like if you did it manually. You could set a variable called sum, or whatever you want to call it, to 0, and then you take the sum, and it should be equal to the current value of sum plus one entry of the array. So the sum starts out 0, and then after you run this first line, or actually second line, but the first one that says sum equals, you're going to be adding 0 and 5. So after this line, you're going to have a 5 stored in sum. And then after the second line, sum is going to be 5 to start with. And then we're going to add the next entry in the array. So we're going to be adding the 5 and the 8, and you're going to get 13. So after the second line runs, you have 13. For the third line, now the sum is 13, and we're going to add my array 2, which is 12. So we're going to add 13 and 12. And we're going to end up with 25 after the third line. Then after this fourth one, we have 25 for the sum, and we're going to add my array 3, which is going to be 5, and should be 25 plus 5, should be 30, and that's going to be the final result of the sum. But of course, you don't want to type 4 lines to add up the sum of a 4 entry array. And what would you do if it was 100 things in the array? You wouldn't want to type them all for sure, right? And so we want to basically do these steps, but instead of writing out the lines manually like this, we want to do it in a loop, which we learned how to do last time. So if you want to add up an array, you just start out with a variable being 0, and then you loop through the entries of the array. So you start a loop counter at 0. We go I is less than array length, so less than the length of the array, and then I plus plus. And then we do sum equals sum plus my array I. And so this right here is going to basically do all four of these lines, right? Because the first time through the loop, we have I equals 0. The second time through the loop, we have I equals 1. Third time through the loop, we have I equals 2. Uh, fourth time through the loop, we have I equals 3. So every time through the loop, we add one array entry to the sum. And if I head over to Eclipse, which should be somewhere, and let's just delete everything in here, just put a couple of 5, 7, 3. We'll just do a short array. If I do sum equals int sum equals 0, and then if I did this, sum equals sum plus my array 0, that's going to take the 5 and add it onto the sum, which is going to make the sum 5, right? And if I do the same thing 3 times, oops, like this, I'm only doing 3 entries instead of 4, like what we had in the example. System.out.println, and I'll just say sum equals, and then I'll say plus sum. When we run this, we get sum equals 15, which is, of course, 5 plus 7 plus 3 is 15. So that works. But then, as we said, you don't have to type these all out. We could make it look like this. Int I equals 0. So we start out at the 0 entry. I less than my array dot length. That's so if the length is 3, we're going to go up to 2. That's what that would do. And then I plus plus. And then inside of the loop, we want to just do the equivalent of one of these lines. The only difference is that instead of saying sum equals sum plus my array is 0, we have to put the loop counter in for the index so that the first time through it's my array 0, second time through it's my array 1, and so on. And if I delete all these then, and we run it again, we still get the exact same answer. And this will work even if we add more entries, because you see 36, it'll work even if we add more entries, because whatever the length of the array is, we're going to be going up to that appropriate index to get the last entry. So it works with if you have an array with one thing, it works if you have an array with, 20 things, works with an array of 1,000 things. Doesn't really matter. All right. So that's how you do it. So we learned how to do this kind of thing, and really everything else in this lecture is some kind of variation of this stuff. So, like if we wanted to find the average of the entries of an array, you add up all the entries just like the sum, right? Because when you calculate an average, you add everything up and you divide by how many things you're averaging. So all you would have to do is to calculate an average, if I come back here, is add a variable to store the average. We're going to need it to be a double. It needs to be a double because normally if you are taking like the sum of an array like this, and then you divide by however many entries there are, you're not generally going to get a whole number, right? So like I have 1, 2, 3, 4, 5, 6, 7, 8 things in this array. And so the average would be 36 divided by 8, which is 4.5, right? So 4.5 is not a whole number, which means that if we want the average to store that, we're going to need a double. So you just add a variable for the average, calculate the sum like normal, and then for the average, it's just the sum divided by however many entries there are in the array. But the number of entries in the array is just the length of the array. So you really just have to add the line that declares the average and the line that calculates the average. And you could even combine them, right? Like if I came down here and I said double like this, then I wouldn't need this up here. So this whole thing would just calculate the average in one line. So if I go ahead and print this out, average AVG run. Oh, there's a mistake. So that's good. I'm glad this happened though. So I ended up with the average being 4.0 which we know is wrong because we just did it on a calculator and we got that it should be 4.5. And that's because, guess what? We've seen this before. When you do a calculation like this one right here, in this case, the sum was an integer and the array length is an integer. So when you do sum divided by array length, that's an integer divided by an integer, which is an integer. So you get the integer version of the operation, of the division operation. And well, if you get the integer version of the division operation, then you won't have any kind of fraction involved, even if there should be. So the solution has to be one of a couple of things. Number one, we could change this int to double for the sum. If I do that and I run it, we'll see this go to 4.5 like it should be, because now it's a double divided by an integer, which is a double. Or I could leave that alone. So we're back to the wrong answer. We learned that you could do typecasting in the computation. So if I were to just write double here in front of sum, that also fixes the calculation. So there's multiple ways to fix that, but you just need to be aware of whether you're doing integers and integers or doubles and integers or doubles and doubles so that you can avoid integer division, which would give you the wrong answer. Okay. Regardless, we now have talked about how to do an average. So that's just the same code that's here. No difference except I wrote out the word average, whereas I used AVG in our example. Now, if you want to find the product of entries in an array, it's almost the same as calculating a sum. But the problem is this. So like, let me just delete the average that we just calculated. So let's just go back to the sum. And you might think like, okay, well, if we were doing this previously, right? So our array, let me just move this out of the way, close that. Okay. So what we're calculating that 36, that's 5 plus 7 plus 3 plus 6 plus 1 plus 2 plus 4 plus 8. And apparently plus 8. And apparently that's 36 if I type that out right? All the entries in the array added together. And you might think, okay, well, if we want to do the same thing, but a product, 5 times 7 times 3 times 6 times 1 times 2 times 4 times 8, and we don't know what that is yet, but you might think that if that's what you're trying to do, all you need to do is change this. Well, we should change the sum to maybe product, and then product equals product, and a product means multiply, so you change the plus to a times, and you might think that this would work, but it doesn't. We're getting an error because I tried to print the sum, but it's actually called product now, and I'll change this to product. It's going to calculate now where it should, but we're going to get not the right answer. We get that the product is 0. And of course, if you look at the code that we wrote, that makes perfect sense, because if we're starting out with the product being 0, and then you do product equals product times my array I, well, the first product is 0 to start with, right? So 0 times my array 0 will be 0 times 5. But 0 times 5 is 0. So you'll get 0. And then the second time through the loop, you're going to get 0 times my array 1, which is going to be 7. So 0 times 7, which is going to be 0. The point is, 0 times anything is 0. And so if you start out the product as 0 and then you start multiplying it by 5, by 7, by 3, by 6, by 1, by 2, by 4, by 8, you still get 0 every single time. And at the end of the day, you end up with 0. So when you're doing a product, you cannot start your product at 0. You need to start your product at 1. That way, when you multiply, the first operation you're going to do is going to be the product, which is now 1, times my array I, which is 5. And you're going to get 1 times 5, which is 5. Then the second time through, you're going to have 5 times, and you'll multiply by 7, which will be 35. And then you'll have 35 times the next entry, which will be 3, which will be whatever that is, 105 or something like that. And then the next time through, it'll be 105 times the next entry, 6, and so on until you get all the way to the end. The point is, you need to start out this product at 1 so that this operation works for calculating kind of a running total, but for a product instead of a sum. So now we get this is the actual product. And you'd be able to verify that if you multiplied out all these numbers, but we don't really need to do that by hand or anything. This should be correct. So if I go back to the preview here, you'll notice that when we did the sum starts out as 0, and then sum equals sum plus my array I. If you need to multiply the entries in the array, the product starts out at 1, not 0, and then its product equals product times my array. Times because we're doing a product. All right, so now we know how to do that. The next thing would be how to count up the entries that satisfy a condition. So how do we do it? So if we're trying to count up the entries that satisfy a condition, whatever the condition is, then first of all, we're not going to be having any product or sum anymore. So maybe I'm going to write count here, count, and I'll make the variable named count as well. So what are we trying to do here? Well, we can do whatever we want. Let's say what I'm going to do is, in my example, I'm going to count how many entries are larger than 5. I should say larger. I should say greater. I'll say greater than 5. Now, how many are there, right? We can count them by hand. Greater than 5. So 5 is not greater than 5, but 7 is. So 1. 3 is not. 6 is. So that's 2. 1, 2, 4 are not. 8 is greater than 5. So there are a total of 3, right? So the total should be 3. Okay. But how would we do that? So if you wanted to count the number of entries that are meeting that condition, the condition is greater than 5, what you would do is you need to create a variable to hold the answer. So maybe int count, and you start it out at 0. So you start a counter at 0. And then what we're going to do in our loop for looping through the entries of the array is very simple. We're going to see if the current entry that we're looking at in the loop meets the condition greater than 5. And if it does, we're going to add 1 to the count. So inside of our for loop, we just have an if statement. If, and then whatever condition you're looking for. So if I want to know if the entries are greater than 5, I have to take the current entry, which would be my array subscript I, and see if it is greater than 5. And if it is, we're going to go inside this part of the if statement, and all we need to do there is add 1 to the count. This is one way to add 1 to the count. So when we run this code, assuming it's working, we should get 3 because we know that there are 3 entries that are greater than 5. And we do get 3, right? Now, if you change this, we could say like 9, 9, 9, 1, 9, 9. I put 8. Like how many entries are greater than 5 now? 1, 2, 3, 4, 5. So there should be 5 that are greater than 5 now. And there are. Right. So this condition here, my array I greater than 5, that could be any condition that you want. And so a common thing that you would have to do, sometimes what you need to do is count the number of things that are negative. So that would be checking if my array I is less than 0, right? I didn't have any negatives here, but if I go and I make a couple of these negative like that, how would you check how many are negative? Well, you would just change the condition here. Instead of greater than 5, you would just want less than 0. That's what it means to be negative, right? And you don't need to change anything else here. Oops. So the count is 4 because I did 1, 2, 3, 4. 4 of them are negative. So counting up things is relatively simple. However, one thing that you might have to do at least once in the Zybooks exercises is check divisibility. So um, consider this. If, let's say, this is an example, but like if you do like a variable, so like number, and then you do a modulo operator, you know that that's the remainder operator, and you pick another number after this. So like I'm going to say 7, but it could be any number. If that remainder is 0, right? So this condition right here, when you do something like this, number modulo 7 equals 0, that means that you've divided by 7 and the remainder is 0. That means that 7 went into the number evenly. That means that the number is divisible by 7. Um, then number is divisible by 7. And you can put whatever number you want there, right? Like if you wanted to know if a number was divisible by 3, then you just put a 3 there, and then it's checking if it's divisible by 3. If you want to know if a number is divisible by 5, you put a 5 there, and then you'd be finding out if it's divisible by 5. So you can do conditions like that as well. So like if I put some numbers here, 1, 3, 4, 9, 6, 7, 12. Okay, so here's some numbers. So if I wanted to check how many of these are divisible by 3, for example, then all I would do is I would want to know if the number modulo 3 is 0. That would check if the number is divisible by, in that case, 3. What do you have to change here in order to do that? Well, instead of my array I less than 0, it would be my array I modulo 3 equals 0. That's how you check if something is divisible by 3. So then if I run this here, we'll get an answer. The answer was 4. So I must have had 4 numbers that were divisible by 3. We can count them. So 3 is divisible by 3. 9 is divisible by 3. 6 is divisible by 3. And 12 is divisible by 3. So far there are 4 different numbers that are divisible by 3. And so this modulo operator would help us calculate those. So that's another type of condition you could check. All right. Um, Another thing we need to do is we need to make sure that we know how to find the maximum or the minimum of an array. And so the strategy here for finding a maximum is this. So you need to set the maximum, you make a variable for the maximum, and you set the maximum equal to the first entry in your array. Okay, so that's first. After you do that, then you have a loop where we loop through the rest of the array. And inside of your loop, you have an if statement. And so if the entry that we're looking at is bigger than the current maximum, then the maximum should be the current entry. That can be a little bit awkward to read, but let's consider an example. So let me say that we have like 2, 7, 3, 5, 9, 1, 4. Okay. So here's my array. Now, what's the maximum of that array? I think we can look at it and see that the maximum is 9, right? So how do we do this to find the maximum? Well, first thing to do is we need a variable to store the maximum. So you make a variable, integers fine because we're dealing with integers, and we need to set it to not 0, not 1. It needs to be set to the first entry of the array. And the reason for that is because we're going to loop through the array and we're going to be comparing these numbers to whatever we think the maximum is currently. And it's possible that if the number you put in maximum at the very beginning of your program happened to be bigger than every entry in the array, then we're never going to change the value that's in the maximum. So like if I wrote this, for example, max equals 999, because that number is bigger than all of these numbers, the procedure that I laid out here, where we loop through the rest of the array, and if the entry is larger than the maximum, then we update the maximum, that will never happen. And so if you start out with a value that's too big in the maximum, we're going to get to the end of this for loop, and we're going to think that the maximum of our array is 999. But of course, that's not the right answer, right? And the way to avoid this issue is actually very simple. You just need to make sure that instead of putting a number that you pick yourself into the maximum to start with, you need to make sure you just pick something from the array. Technically, it could be anything from the array, but definitely the standard thing is just to put in the first entry. So in the code that we have here, what this line is going to do is it's going to take a 2 and it's going to put that 2 into the maximum. And then we can continue on our way. Okay. Now, once we do that, we set the max equal to the first array entry. Then we want to loop through the rest of the array. Now, we already have the machinery here to loop through the array, right? I have a for loop, which ends down here somewhere. And then in the loop, we just do this. If the entry, and so when you start, we've done a lot of loops with arrays now. We should know that the entry is going to be my array subscript I. So if my array subscript I is larger than the current maximum, then make the maximum equal to the current entry, which again, it's going to be my array I. So what do we do here? It looks like this. If the current entry, which is my array subscript I, is greater than the maximum. So we're trying to find the biggest number in here. So if the number that we're looking at is bigger than what we currently are calling the maximum, then that means the maximum is not really the maximum because this entry is bigger. So in that case, where my array I is bigger than the maximum, we should make the maximum equal to my array I. So what this does is as we go through here, this if statement is going to look at, the loop is going to loop through every entry in the array. And this if statement is going to store the number in maximum if it's the biggest number we've seen. So first time through the loop, we're going to be comparing 2 to 2 and nothing will happen. But the second time through the loop, the maximum is going to be 2 and the current entry will be 7. So this will be if my array I, which is going to be 7, is bigger than maximum 2, which it is, then we're going to change the maximum to be equal to 7. And so as we go through, we're storing the biggest number we've seen so far. So like after we've seen the 2, the maximum is 2. After we've seen the 2 and the 7, the maximum is 7 so far. After we've seen the 2, the 7, and the 3, the maximum is still 7. After we've seen 2, 7, 3, 5, the maximum is still 7. After we've seen 2, 7, 3, 5, 9, the 9 is bigger than 7, so we're going to change the maximum to be 9. So now the maximum is 9. And then once we've seen 2, 7, 3, 5, 9, 1, the maximum is going to be 9. And after we've seen the entire thing, the maximum is going to be 9. So we only change the maximum if the number we're looking at is bigger than the maximum. So we're keeping kind of a running total of the biggest number that we've seen. And that's the logic for how this works. So if we did all this, we can print out the maximum. And if we did this right, it should tell us that the maximum is 9. And it is. Okay. Now, what about a minimum? If you wanted to calculate a minimum, the idea would be essentially identical. Of course, instead of max, you should probably call your variable min, right? You don't want to call it max. If you change it to minimum here, you would need to change it to various other places, there and there. And the big change in the logic is actually just instead of if the current entry is bigger than the minimum, well, sorry, instead of being like we have up here, if the current entry is bigger than the maximum, change the maximum. For a minimum, we're looking for the smallest possible value. So we wouldn't want the entry in the array to be bigger than the minimum. We would want it to be less than the minimum. So you just flip that inequality around, and other than that, the only thing that changed was the name of the variables. So if I print out the minimum of our array, let's see what it prints. 1. And if we look at our array, I think we can see that, yes, actually the minimum is indeed 1. So that was a maximum. Here's the exact same code. How to find a minimum. Again, we just did this, but the only thing is this is a less than, whereas for a maximum, it's a greater than. And other than that, the only thing that changed was we changed the word max to min in the variable names so that, they were meaningful variable names. All right, that is it. So I don't really know how long I've been talking so far. My guess is about a half hour. Um, so let's do some exercises. We'll jump to the week 10 homework and we'll do some of these. What? This was not linked. Okay, well, I better fix it. I'm going to fix this for the other assignment as well, since apparently I forgot. Oh. Week 10 reading. Okay. So let's refresh this, head back over to Zybooks, and that should be corrected now. And yeah, so we're going to jump to these kind of later exercises. So we only did up to 10.3 last time. We'll do one exercise maybe in 10.4. So they're talking about maximum. So actually, this is good because we just did this. So when it says click store value if a new maximum value is seen, what you do is if you need to update the maximum with a new value, you do so. So like right now, there's no maximum and we've seen 7. So what's the biggest number we've seen? 7, right? So you click store value and there's a 7 there. Then you look at the next entry. If that's bigger than 78, or sorry, if 78 is bigger than the current maximum, which is 7, then we update the maximum by clicking the button. So we should, right? 78 is bigger than 7. Now, if we have 1 and the maximum is 78, well, the biggest number we've seen is still 78, right? So we don't click the button this time. We only click the button if we see a number bigger than what we think the maximum is, right? Click store value if a new maximum is seen. So 5 is not the maximum. 94. 94 is bigger than anything we've seen. So click the button. 93. Nope. 93 is smaller than 94. 18. No, 18 is smaller than 94. Right. So we got the correct maximum. All right. This is the like equivalent of how do you count up how many things satisfy a condition. So the condition is negative numbers. So every time you see a negative, we add 1 to the counter. So we see a negative, add 1 to the counter. We see a negative, add 1 to the counter. Not negative, not negative, negative. So add 1 to the counter. Not negative, negative. So add 1 to the counter. So every time we saw a negative, we bumped up the counter. And that's how we count how many negatives there are. All right. So they were explaining a concept there, but now they want us to actually write code to do this. So they're teaching us how to iterate through an array, but we already talked about that ourselves. Um, so let's find some exercise to do. Let's do, I don't know, let's do this one first. Um, Determine the minimum number in the array using the same initialization as the maximum number example above. So um, when you are calculating the minimum value or maximum value, you need to start by putting the first entry in the array into the minimum or maximum. So apparently our array is called myvals, so it should be myvals 0. That's the first entry. And then we loop through our array. I guess that's all we did there. How many negative numbers exist in an array? Well, you set a counter to 0. And then every time we see a negative number, we should add 1 to the counter. Now, when I was adding 1 to a counter, I don't have one here, but I was doing, normally like count plus plus like that. But in this case, plus plus count would have done the same thing. So don't worry about the pluses being first or not in this scenario. So what should we be doing to count negative numbers? Every time we see a negative number, we should add 1 to the count. So you have to look at this and say, what's the array? And if you see this right here, myvals.length, then you know that the array's name is myvals. So myvals. And in the loop, we're looking at the one with a particular index, one particular value from the array. And we see that the counter is I, so it should be myvals I. And we want to see if, in particular, that value is negative. So we check if it's less than 0. All right. Calculating odd numbers. So this is just another condition. You know how we said that you could check if you check the remainder and the remainder is 0, that means that the number went in evenly. So if myvals I modulo 2, if that was equal 0, so if this was a 0 here, that would mean the number was divisible by 2. Divisible by 2 means even. But this isn't equals 0. This is equals 1. So that means you divide by 2, and the remainder is 1. Well, so it's not even. If you have a remainder when you divide by 2, it's not even. But integers are either even or odd. So this is checking if my vowels I is odd, right? So what do? Well, we check if the condition is true. In this case, the condition is the number's odd. And if it is odd, we should add 1 to the counter. So all you got to do is take the counter and we need to add 1 to it. So CNTODD. Now, do they want plus plus or at the beginning or the end? I don't know. They said this was fine, although they put theirs first. All right. Now, these are not exercises that need to be done for points. So I'll just skip by them. But let's go to the challenge exercise. So we're not going to do all of these, but we can do a couple maybe. So start. What is this doing? Type the program's output. So there's an array. The array contains 149. Then we're looping through the array and we're doing system.out print line user vals I. So what are we doing? We're printing the 1, the 4, and the 9. Okay, we're looping through the array and printing one value each time. So that's 1, 4, 9. They're all on different lines because this is a print line. Cool. Let's skip to number 3. Okay. Now this is something that we haven't really had to do, but I will show you it over here. So I'm going to delete most of this. So I'm going to change my array just to have 3 things in it. So if I do this for int I equals 0, I less than my array dot length, semicolon, I plus plus, and then in here I just do system dot out dot print line, my array I, then this is going to print my array 273, right? 273. But if you think about what this loop does, right? The I starts at 0 and counts up to the length, actually length minus 1. So if there's 3 things in the array, it's going to count up to 2. So this is 0, 1, and 2 is what you get in that loop. Okay? Now, I'm going to comment that out. Do another one here. Now, what if we did this instead? What if instead of starting at 0 and going up to 2, we started at 2 and went down to 0? So what that would look like is int I, and instead of starting it at 0, we'd start it at 2. And then we wouldn't want I greater than 0 to be the condition to keep going. Or sorry, we wouldn't want I less than the length to keep going. If we're counting from 2 down to 0, the condition for keep going is that the I value should be greater than or equal to 0. So we're going to start at 2, keep going while this is a positive or at least a non-negative number. And then instead of adding 1 every time like we did here, we want to subtract 1 every time. So this will start at 2 and go to 0 instead of starting at 0 and go to 2. So when I run it now, we get 372. So it counted the numbers backwards, 372. Okay. Now you may notice that in the original version of this that started at 0 and went up to 2, that we were using the array length to get the 2. I mean, the array length is 3, but we know that when we use less than array length less than array length is going to go to 2 when the array length is 3 because it'll stop one early. So this 2 here could have been the array, uh, my array length, but not my array length because my array length is 3 and we're trying to start at 2 here. So you need to do -1. So that's the same. So you should be able to look at this version of the for loop, I equals 0, I less than array length, I plus plus, and realize that that's starting at 0 and counting up. But you should also be able to look at this version of the for loop, see that this is starting at the length -1 and counting down. You can see that from the I minus minus, and it's counting down to 0. And that should, um, now that we've seen it, we now know that this is a loop that loops through the array, but specifically, instead of starting at 0 and going up, it's going to start at the end and come down. Okay. And with that understood now, when you look at this, you should just recognize this structure as looping through the array backwards. So this is looping through the array backwards. So instead of printing 2, 6, 7, it's going to print 7, 6, 2. Okay, let's skip one couple. All right, so we got -1, 3, 6, -7, just an array. This one's going through in the normal direction, right? Start at 0, count up. And it says if the current entry is less than 0, we're printing it. So this is not adding up or counting the negative entries. What this is doing is if the entry is negative, then it prints it out. So this is going to print the entries, but only the negative entries. So it's going to print -1. It's not going to print 3. It's not going to print 6. And it will print -7. Right? So if the entry is negative, print it. Okay. We'll do one of these. Let's do this one. Array test grades contains num values test grades from input. Okay, so we don't really need to care about where they come from. But like these are examples for the grades. And apparently what we're trying to do is calculate how much extra credit there is. So uh, it's extra credit if it's over 100. So this is 101 is 1 point of extra credit, and 107 is 7 points of extra credit. So from the 101 and from the 107, that's a total of 8 points of extra credit, right? And that's what we're trying to do. So what does that look like? So if we wanted to try to do that ourselves, that calculation, we're going to need to loop through the array, right? So we'll loop through the array. So there's two kind of choices for how to do that. This one says less than test grades dot length. This one says less than or equal to test grades dot length. Hopefully we've seen enough of these now to know that it should be less than, right? You don't want to go up to the length because the last entry is actually one less than the length. So we need less than, not less than or equal. So let's start there. I always put in the curly brace at the end now rather than wait. So there's a loop. Now we need to figure out if there's extra credit. So full credit is 100. Any grade over 100 has extra credit. So we should check if there's extra credit for the current number. So this one says if test grade is less than 100, do something. This one says if test grade greater than 100, do something. So we want to do something if there's extra credit, right? So I want this one that should be indented in there. That opened another curly brace, so I'll go ahead and drag the closing curly brace down there. What do we do if there's extra credit? Well, if there's extra credit, we need to uh, add the extra credit to the sum. Now, there's only real one possibility here, right? Some extra equals some extra plus the grade minus 100. And if you think about what this is going to do, like imagine that the test grade is 107. If the test grade's 107, this right here, test grade I, that'll be 107. 107 minus 100 will be 7. That is the amount of extra credit. And we want to add that to whatever the current amount of extra credit is. So this is the correct thing to do. So it should go in there. Now, the only problem left, like we've got all the structure of the code correct, but if you look at the variables, this variable sum extra, where we're supposed to be keeping track of the extra credit, has never had a value in it to start with. So this line here, sum extra equals sum extra plus something, is going to fail because there was no value in sum extra the first time. So over here, I see sum extra equals 0, and we just need to do that before the loop gets started. So here. That should be correct. So we'll just hit check, but it should just be correct. Okay. Alrighty. So we'll do one or two of these. Start. Maybe we'll just skip to second one. I didn't really read the first one. I just figured this one will be slightly harder, right? So what's it say? 10.5.4. Given the integer array average salaries with array length elements, write a for loop to initialize the first half of average salaries with the integers read from input. First half. Okay. So normally when we're looping through an array, it looks like this, right? Uh, Now we wouldn't type int I equals 0. Like I've typed this a lot, right? Like, let me just zoom in. I've typed int I equals 0 a lot. That's wrong in this case because they've already declared the I variable up here. So you need to delete that int. But that said, our normal way of looping through an array is I equals 0, I less than the array length, which, um, you could do average salaries dot length, or because there is this constant, you could just use the constant that's also the array length, and then I plus plus. And then in here, it says we're supposed to be reading the values into the array. So the array is average salaries, and the current entry is average salaries I, and it should equal, well, we're supposed to be reading it from the keyboard. So scnr dot next, and it should be an int, right? Now I hit save. This is wrong. This is wrong because what this is going to do, if the array length is 6, this is going to read 6 numbers into the array. And they specifically said first half. So the array, even though it has 6 things, we're only supposed to actually read 3 things into the array. So all we got to do is, to fix that, is to go where they have array length and just divide that by 2. So instead of, if the array length is 6, we're only going to read 3 numbers in now instead of 6 numbers. Other than that, this is a basic loop through the array type problem. Okay. Last one. Last one in this section. Given the integer array average prices with num values entries, so similar to the last one, write a for loop that assigns sum vals with the sum of all the integers in average prices that are less than 86. Okay. So like if you look at this right here, right? The thing is, I'll open a calculator. So what you're doing is this. So some of these numbers are bigger than 86 and some are smaller than 86. So it wants us to take all the ones less than 86. So like 81, not 97, 77, not 119, not 116, not 105, 40. 86 is not less than 86, and 41. So these are all the numbers that are less than 86, and we want to add them, and we get 239, and that was what we were trying to do, apparently. Okay, so what do? Loop through the array, check the number if it's less than 86. If it is, we add it to this variable that we're going to keep track of the thing in. So what do? Well, first of all, most of these problems actually are going to have loops to loop through the array already. So like there's one right here. So I can be lazy. I can take their array or their code for the loop, steal it, and we'll just delete what's inside. So this is my code for looping through an array. What do we need to do for the array? I'm getting sneeze. Ah, should have muted that, but I didn't. All right. So what are we doing? Looping through the array. If the numbers are less than 86, we do something with them. So if the current number, which is average prices I, if that number is less than 86, what do we do with it? Well, we need to add it up, right? So there's a variable that is going to keep track of our sum. So the variable we can see, like it says, sum the values below 86, sum vals. This must be where we put the answer. So if the average price is I less than 86, sum vals equals sum vals plus the current entry in the array. Now, this has the same problem that we had on the last one, I think that we did. Well, maybe not the last one, but a couple ago, which is we need to make sure that the sum vals is starting out with like a zero already in there, because I think if we scroll up, we see that I don't see this value sum vals ever being assigned a number, which means we're going to get an error when we try to run this line, unless we just set this equal to zero to start with. So we need that extra line. So this should work, and it did. Okay. Multiple arrays. All right, so this is not really anything new or even particularly complicated. I don't know why they really make it its own section, but look at this. Here's an example. So let's just say I did this. I just said like let's say age, and I go 12, 15, 20, and then I go int and I go, I don't know, price, and maybe I make the prices 5, 5, 10. So maybe like, 20-year-olds pay more for something. I don't know. The point is really just that I've got two different arrays, but they're both have three things in it. And so when you have two different arrays, but they're the same length, sometimes they could be related in some way. So maybe you're going to look up the age, and if the age is something, you're going to, based on the age, you're going to do something for the price. I don't know. Um, and that's all they're going to talk about here. So like what we've got here is this is some kind of post office thing. So they've got weights. I guess these are ounces. So we have weights and ounces here, maybe. Oh, it says it actually. It says ounces right there. And then this was postage in, they say 2017. They could look up current values, but they're too lazy. So what is this saying? They're saying if the weight is 1, the postage is 49. If the weight is 2, the postage is 70 cents. If the weight is 3, the postage is 91. Okay. So then somebody is typing in a weight, and then we're going to be looking through the array to find out how much that costs. How are they doing that? Well, they're going to compare what the user typed in for the weight to the numbers in the weights. So what does that mean? Like, so imagine this. So like, let's say I just, I, oh, that's not what I wanted. Uh, I don't want to use a like notepad because it's too big on the page. So like, let's say somebody types in a number, like let's say they type in, um, like they're not going to be whole numbers necessarily. So like let's say I type in the like 4.7 ounces. So like let's say 4.7 ounces is the weight. Then what it's going to do is it's going to start at the beginning here, and we're going to find the first number that's bigger than 4.7. So 1 is smaller than 4.7. 2 is smaller. 3.5 is smaller. Sorry, 3 is smaller. 3.5 is smaller. 4 is smaller. 5 bigger, right? So the 5 is bigger than 4.7. And then we're going to do that in a loop. So we'll know the I value for this. So the index. So what index is 5? It's 0, 1, 2, 3, 4, 5. Okay, so actually the index for 5.0 is 5. So because that's 5, index 5, you come down here and find index 5. 0, 1, 2, 3, 4, 5, and you get 182. So that's the postage. That's the postage for 4.7 ounces. So you looked through here until you found a number bigger than the 4.7. And then however many entries that was, 0, 1, 2, 3, 4, 5. You found the corresponding entry down here, 0, 1, 2, 3, 4, 5, and that's your postage. Okay. And that's what they're doing here. So yeah. Do we have let's just jump to the challenge exercises, see what they look like here. So integer array total records list contains num values elements read from the input. They do that. We don't have to. Declare an integer array thrice records list. Okay. With num vals element. So we have to make our own integer array. So we have to remember how to declare arrays. Integer array, the name that they gave us. And actually, we can just steal the rest of this. We could have stolen the whole thing. But okay, declare an array. Then assign each element of thrice records list with the corresponding element in total records list multiplied by 3. So there's two arrays now. There's the original one called total records list, and there's the new one that we're making called thrice records list. Thrice means 3 times, right? So basically, if the original one is here, we're going to multiply all those numbers by 3, and that's what we're going to put in our array. So we need to go through this array, take this, multiply it by 3, and put it in the first spot. Take the 65, multiply it by 3, put it in the second spot. Take 31, multiply it by 3, put it in the third spot, and so on. So all we got to do here is make a loop to loop through the array. There's actually several to pick from, so let's just copy paste this one. Delete the insides. And what are we supposed to do now? Well, our our new array is called thrice records list. And what we need to put into the I entry is the corresponding entry from total records, which is total records I, but we want to multiply it by 3. So you just put a times 3 on it. And so this code right here is going to multiply the total records, all the entries by 3, and then store them in this new array that we made up. That's it. Right, let's look at the next one. Actually, I jumped to number 3. Okay. Integer arrays, member grades, and years of experience. So are these the member grades and are these the years of experience? I don't know. Um, for each element of years of experience, so we're going to loop through it, right? Because it says for each element. If an element is less than 30, output members grades corresponding element followed by a space. Okay, so this is one where what they're asking us to do, like, it's not clear why they want us to do this. It's not even really clear what they want us to do, but if you take it step by step, you'll be able to do it. So, forget the why. Let's just do what they say. So it says for each element of years of experience. So we're looping through years of experience. So I'm just going to take one of the loops here that's already looping through years of experience, paste it, delete the inside. Okay, so I've got a blank array or blank loop. Okay, now it says for each entry or each element of years of experience, what? If the element is less than 30, right? So if an element is less than 30. So in here, I need to do if an element is less than 30. But what's the element? Well, the element of years of experience, because it said for each element in years of experience. So years of experience, I, is what we're talking about. If that is less than 30, we do something. What something? It says output member grades corresponding element. So we are making our decision based on years of experience subscript I. But what we're going to print out is member grades subscript I. So we'll do a system.out.print, and it says output members grades corresponding element. So that will be members grades subscript I. And then it says followed by a space. So followed by a space. And then it says after the final output, end with a new line. So that means after our for loop that we just wrote, we need an extra new line, which I usually do with system.out print line, and I usually just put nothing in it. And that'll give us a new line. So if years of experience I less than 30, output members grades subscript I. So we're making the decision based on an entry in years of experience, but the thing we're printing is an entry of the other array. So just two different arrays at the same time. All right, we got a typo somewhere. What is the typo? Let's see. The typo is it's member grade, and I typed members grades. All right. Now we got it right. I still don't know what we were doing. Like, I don't know the purpose of this code, but without even knowing the purpose of the code, I was able just to look at each little piece and write the code anyway, right? We don't need to know the purpose of the code if we can understand, um, you know, We don't need to understand why they want us to do it. We need to understand what they want us to do, right? Those are not the same thing. All right. So that is the majority of this. So there's a little bit of stuff here at the end, but we don't have time to go over it right now. So I'm going to go ahead and stop this here. And, maybe we'll have some time in the next lecture just to finish off some stuff we didn't see here. That's it for now. Talk to you guys later.